Hi, and welcome to another exciting episode here with me, Carmel Fisher, on the Harvest podcast. Yes, this is where we're bringing you a spotlight series on nuclear energy in alignment with the Dealflow Events Discovery Day coming up on May 22nd in Midtown, New York City. This event will convene the thought leaders, industry experts, and breakthrough companies at the forefront of the nuclear energy sector. This sector is experiencing a global renaissance due in part to the increasing interest in clean energy driven by the needs of data centers and AI technologies. Nuclear Energy, the Discovery Day, will provide a forum to uncover new insights, investment opportunities, and exchange ideas with industry stakeholders. So we're very excited to also present and spotlight companies who will be offering their innovative breakthrough initiatives in the sector. And one of those companies we're spotlighting today is Deep Fission. With me, I have CEO Liz Muller. She is the CEO of Deep Fission, but also co-founder and board chair for Deep Isolation, inventor and author. Liz, we are so excited to uncover more about your background and the future of nuclear energy. Welcome to the show.
Thank you so much, Carmel. Happy to be here.
Very excited to uncover. You've got such a colorful background and history and career. You're at the forefront of a really pivotal industry at the moment, and I can't wait to hear more about your visions and your inventions for the future. So, as a start, tell us a little bit more about Deep Fission, the mission and vision. Why did you found it? What is it all about?
Yeah, so I will back up a little bit further into Deep Isolation, the previous company that I founded. And Deep Isolation was born out of some personal frustration that we were not doing more when it came to nuclear power. And I lived in France for many years. And when I came back to the US, particularly in the Bay Area in California, where I live, there's this not a lot of support for nuclear power. And the number one reason that people gave was the unsolved nuclear waste problem. So I got into deep isolation because I felt like we have to make progress on solving the nuclear waste problem, specifically the nuclear waste disposal problem. But as deep isolation got going and as we got closer and closer to really solving that problem and to having customers all around the world, something else became of increasing concern to me, and this was cost. And I started to worry that even if we are able to solve the nuclear waste disposal problem, it's not clear to me we're going to be able to have the level of nuclear resurgence that I believe we need because nuclear is too expensive. And so I've been thinking about cost of nuclear for a long time and how do we drive down the cost. And of course, what many of your listeners might know is that the reason nuclear power is expensive is fundamentally because of the construction cost. So it's building the facilities, it's the cement and concrete and steel and all of the structures, and then the nuclear quality assurance that needs to go on top of those structures. And there are estimates between 80% and I've even seen 93% of the cost of nuclear power is in those physical structures. So I think there's a lot of interesting innovations happening right now. How do we reduce that cost? And we see some companies taking a manufacturing approach by mass manufacturing. And we see other companies trying to use new materials that maybe don't require the same levels of pressure. But what Deep Fission has recognized is that when you're in a borehole a mile underground, you already have the conditions that you need to replace that construction. So we don't need the construction. We already have the pressure that we need because we're a mile underground, and we already have the containment that we need because we're a mile underground.
Incredible, and just really thinking strategically about the current position and what more you can do to further the renewable approach to this and the cost savings approach.
Yeah.
Given your extensive experience in both nuclear waste disposal and climate data with Deep Isolation and Berkeley Earth, what specifically motivated you to found Deep Fission and bring this unique underground reactor technology to the Discovery Day nuclear energy event coming up soon?
Yeah, I'm really excited about some of the potential, the customers that Deep Fission already has, and the ability to bring this to market quickly. So, I was talking about the cost previously and the incredible cost reductions that we're able to bring, but there's also a significant reduction in the time to market. Because drilling, we have the expertise that we need in order to drill holes a mile deep. We can leverage existing technology from the oil and gas industry. So we're looking at a time frame of construction of a few weeks per hole in order to build the hole, and then in terms of getting the equipment down there, we're looking at a total of about 6 months from the time that we are approved to build the reactor in order to be operating commercially. And so that's really exciting, and one of the I think big one of the exciting parts about the future of nuclear in Deep Fission is that how quickly we're able to move in addition to lowering the cost.
Very important, it appears, obviously, to get things moving as fast as possible, given the demand out there. So obviously there's an emphasis on the use of standard PWR technology. And as you've mentioned, it will translate into faster regulatory path potentially. And what key conversations are you currently having with the NRC as of now?
Yeah, so by leveraging the existing pressurized water technology, we are engaging with the regulator in something that they already know really well. So there are hundreds of operating pressurized water reactors around the world. There's a lot of certainty with regard to the programs that we're using and the models that we're using, that makes it a faster path to getting that regulatory approval. We are doing it in a different environment. So that is sort of the new component. So we understand pressurized water reactors really well. Doing one a mile underground is something that's never been done before. So there is still a novel component to it, but we're able to leverage so much of what already exists, including the supply chain, as well as the expertise.
Awesome. And speaking about this 30-inch borehole concept and the modular scalability of Deep Fission, it does seem all really revolutionary. Can you explain how this physical design addresses the traditional challenges of nuclear plant siting and the practical benefits for diverse customers like large cities, military bases, and of course, data centers, which is on
Yeah.
everybody's lips these days?
Absolutely. I mean, I think that there's a number of things that are addressed more easily when you have a modular approach. You can increase demand, so it's not nothing and then a gigawatt, right? You can scale up as your customers are scaling up. You could add more power as you go. There's also more flexibility to go to smaller scales. And so if you have a customer who only needs 15 megawatts or 30 megawatts electric, you can deliver that. And that's an important element for certain customers around the world. Now, we're definitely seeing the most demand right now from data centers, and we're also seeing that they need a lot of electricity. So that feels like it's the fast path to market. And we're also seeing that not everybody is interested in building a first of a kind reactor. But if the cost is right, then I think that there is an opportunity to do this, and we've already signed up Endeavor Data Centers as our first customer. So we're moving forward with that today, and then of course expect also to eventually be working with utilities and small communities around the world.
Excellent, and congratulations. Just to remind our audience again that to your point about coming into closer proximity with utilities, the Discovery Day will house, all of these industry stakeholders, including utilities, financiers, site developers, technology providers, and government entities. So do yourself a favor and be part of this conversation, which will really lead the new era of nuclear energy. And this is happening again May 22nd in New York City. That is Midtown New York. We look forward to seeing you there. Mentioning accessible fuel supplies, Liz, rather than relying on foreign sources. In today's geopolitical climate, how crucial is this aspect for Deep Fission's technology for ensuring energy security and stability?
Yeah, I think it's really important. I think that we we've seen that global supply chains can be broken, I think, more quickly and easily than any of us expected. And being able to use existing fuel, the same fuel that PWRs today, pressurized water reactors, are using today, the existing supply chain, I think, is a hugely beneficial. Now, we can eventually move to more other types of fuel if we wanted to. But I think in terms of the fastest path to market, it just makes a lot of sense to start with what we already have and what we're already using commercially today.
100% makes total sense. And then the goal of commercial reactors operational within 3 years of site confirmation. What are the main milestones Deep Fission needs to achieve, and what excites you most about the potential impact that Deep Fission will have on the future of clean energy?
Yeah, I'll break it down into two sort of big phases. The first is we've got to get to market, and we've got to get to market as quickly as we can. And we've got to prove that not only does this work, but that we can produce electricity competitively. And importantly, we want to be profitable and competitive from the first of a kind. So that's really exciting, and that's our first milestone. Now that means we have to confirm a site. We already have our customer, but we're working on confirming that first site. We need to finish our design, so we are still working on that. We still have a lot of engineering that is happening in parallel with the confirming of our first site. And we are already in pre-application engagement with the nuclear regulator, and we need to continue to do that until we can submit our license application. Then we need to go through the license application process, and then, of course, we need to build the reactor, which thankfully is fairly straightforward and quick. Once that happens, then I think it starts getting really interesting. So once we've proven that we can do this, that we can do it quickly, that we can do it safely, that we can do it efficiently, and that we can do it profitably, then I think we're going to see a huge transformation around the world with people switching from other types of electricity, from dirty types of electricity, from unreliable types of electricity to nuclear power. And eventually I can even see additional innovations on the Deep Fission model. So we're starting with a pressurized water reactor in a borehole a mile underground, but why not open up a whole new ecosystem of different types of reactors that you can put in a borehole, again, sort of leveraging the safety benefits as well as the cost reduction potential by using the natural properties of the rock a mile underground.
Fascinating indeed. And I would just want to remind the audience here that alongside Liz and her team and Deep Fission and the multitude of other companies and panelists and industry thought leaders that will be present at this event, be sure that you join us and lead this conversation and keep abreast of all the innovative significant developments underway currently and get that first mover advantage. Liz, this has been fantastic. I am so excited to meet you in person, to hear more about the insights that Deep Fission has for us. And we'll just wait until then to find out more. So thank you for being here with us, and you guys stay tuned for more.
Thank you so much.
Brought to you as always by the Harvest Podcast, available anywhere you listen to podcasts.